Hi, my name is Abu Francis, and I'm making this series of short videos about 18 to 25 minutes or so, which explains this software called TAD, which I have written and which is available free on the net. And I hope by seeing these videos, you can actually get to use TAD really effectively. Now, in the first two videos which I made in this series, they were all on how to use TAD directly, hands-on. There were not much concepts in that because I wanted you to really enjoy how you can start modeling in TAD. And the first video was just that. It was not doing anything accurately, but very quickly you can go around figuring out some kind of a design with 3 rooms in it. The second video had explanations on how you can be pretty accurate in your modeling. And for that, I showed how the architect can be placed very accurately. Now, there is something called the architect inside the software also. It's a metaphor of the architect designing as if he's actually there inside the software. And to assist him, there are 2 further helpers. So there are 3 different persons in that particular software to go around helping you work out your design. The third video which I made was more conceptual, where I was explaining the backdrop, why TAD emerged, and why is an architect who had to write something like this, and why is it that I could not write this software on top of something else which is already existing. And that's a very common question which people ask, that why did you have to do the whole programming all over again? Anyway, so now we are in the 4th video where I'm going to explain how we are going to really edit these shapes. Now, once again, I'm not going to really do it very accurately because you have to refer to that second video of mine which shows how the accuracy can be obtained. But in this video, I'll be talking about some very hands-on thing also, and I'll also give you the backdrop on how people expect editing to happen. So for that, I have a software called NanoCAD. I don't use AutoCAD, but NanoCAD 5 is available free on the net. You just have to register and it's completely free. It's pretty nice software, I thought. It's some Russian company which has made this. And that's got a pretty good idea about what how I can explain the difference between your expectation of regular editing, which happens in, say, AutoCAD or NanoCAD or whatever, and then I will compare that with what I am doing it in TAD, because here there is a very important difference. Because when you look at editing in TAD, you'll find that editing in TAD is very different from editing in CAD software. Not that it is complex, okay? It is not at all complex. You can understand it in a few minutes. So here I have opened in TAD the default model, and what I'll do, just to make it a little convenient, I will move this Chhajja. Chhajja is the sunshade which is there in this default model, and I'll start editing this. Like to give you a revision of what I had shown last time, I already showed you something like stretch. So you can click on this, keep the helpers at the edge you want to stretch, and it kind of stretches. Now I've stretched it into a kind of a roughly a square. Now I'm doing all this very inaccurately, but as I explained in the second video, you can go around placing the architect very, very accurately, extremely accurately, if you want to, whenever you want to. And that's the beauty of TAD. It does not dictate that you have to do everything very accurately right there and then, nothing of that sort. Okay, so the thing which you have to hold in your mind is this, like a rubber band. Okay, so this rubber band is a pretty useful tool. Let me see whether it is being displayed correctly, and take a look at the webcam part of it at the bottom right corner of your screen. And I'm trying to hold this. I wish I had got a thicker rubber band. I hope you can see this. Now this rubber band, I'm stretching it to kind of imitate the shape which you see in TAD over there. Now I'm shaking my forefinger of my right hand. As you can see, Okay, before that, let me just move the helper to the right corner. So the helpers are on the top corner. So the finger which I'm shaking, that is the first helper. The finger now which I'm shaking is now the second helper. So this is the red dot and this is the blue dot. And think of that shape as something which is actually stretched tightly over there and held back onto that side by 4 pins, right? I mean, that's a good metaphor actually. I teach, whenever I teach employees and all who come to my office, this is the way I teach them how to do editing in TAD. Now what I do is that I will remove this first helper. Now when I remove it, as you can see, it has become a triangle. So let's do the same thing here. What I do is that wherever the first helper is, take a look at the mouse now on the screen inside TAD. Now what I'll do is that I'll press Control Backspace, which is a command to delete that particular vertex. And this is removed. So you can do with this particular button also if you want to. But Control Backspace is, I think, good enough. So immediately, just like the way you saw here in this, it has become a triangle. And this is a nice visualization because you remove that pin, it becomes a triangle. If you remove this, these two lines actually will become one. So if I press Control Backspace again, it looks as if I have drawn a line. Actually, it's not a line. It's still a closed shape, excepting it has become both the lines are coincident on one on top of the other because it's very mathematically very precise. So the moment that particular vertex has disappeared, it collapsed into a line. If you delete that vertex also, it will become a point, which I don't want to do it because it's pointless. So what I now do is that I'll undo these shapes. As I told earlier, TAD has got a lovely undo system that each object which you edit preserves its own undo history separately. So because of that, whenever you are editing TAD, you can selectively choose which all objects needs to be undone. So this is a pretty non-linear way of undoing things. So it saves a huge amount of time because many times you carry out a series of edits and then you want to undo something earlier but not something after that. You have some specialist undo requirements as a designer, and I can't understand why other software has never solved this problem. They insist on undoing everything and then redoing everything like that. That's crazy, and this ends up with people saving interim files and all kinds of things. Anyway, that's a small digression. So let me undo that because I want to show you some other editing also. So now you know what is the way by which TAD is actually internally visualizing, or you can say modeling that particular shape. It is really thinking that it's a stretched rubber band over there and it is always going to be closed. There is no way that in TAD you can delete one particular edge. This actually sometimes confuses people. They'd ask me that, I just want to remove that one line and then attach one circle over there, an arc over there and all that. And I'll show you how you can do that here, but you really do not delete a line. There is no concept of deleting one of the lines which forms a closed shape. This is a very, very specific requirement of modeling in TAD. And very shortly you will get convinced why that is so important. But before I get into the conceptual parts of it, let me show you the other commands which is there. Now just like deleting a vertex, so the first helper played a big role there because you're deleting that one vertex. Now if your mind's eye is on this vertex but you press Control Space, you will get confused because you thought this would delete but something else deleted, and then you have to say, oh, what just happened? I thought this is going to delete. No, it is always going to be working on where the current helpers are, and more than that, it will be working on the first helper predominantly, many of these commands. Now I'll show you another one, which is to stretch this particular vertex to wherever the architect is located. So that is like, I hold this particular rubber band, and then I am stretching this. As you can see, I am stretching that finger and the rubber band itself is getting stretched and that closed shape is now taking on a different shape. Okay, so that you can do by pressing F5, or you can press this particular button, which is this shift corner button. So I press F5 or I press that. I just now pressed F5, and as you can see that that particular shape has got modified to there, right? It has got shifted over there. Okay, so that's the shift corner command. You can also add an additional corner. So suppose I say, sorry, I accidentally drew a rectangle over there, and as you know from the first video which I had made, if you draw a rectangle in an empty area, it will think that you are wanting to put in a shape over there. Now I've located the architect at some location here. Now what I will do is I'll press F6. Now what F6 does is it takes the first helper, goes to the architect, and then returns to the second helper. So it actually adds, I wish I had one more finger there. Let me see if I can do that. So this is my, I've stretched the rubber band with these fingers. Now I'll use this finger to add one additional vertex there. And as you can see, it has become a 5-sided figure. So let me first undo this, and now I will add this particular corner. So as you can see, it has actually become a 5-sided figure because I added one corner there. Okay, now these are all to do with corners. So these three buttons are all to do with corners, but these two buttons rather, are to do with the edge itself. Even the third one, actually here also there are 3 buttons here, but let me first show you this one. This is quite different, which you will understand what it does. So now what I'll do is that I will take the architect here and I'll stretch that edge. So it will actually go further towards it. The side angles do not change. So, oops, sorry, I used the wrong command. I'm sorry. I used the F5 command. I should use the Shift F5 command. So Shift F5 or this particular button here, and you can read the hint which is given, that will stretch that particular edge over there. So I press this. Okay. Now there's another one which is called extrude. Let me undo this. Sorry. Now there's another one called extrude. What it does, it actually adds 3 lines, which is Shift F6. So it's adding 2 corners over there, and you'll see how it adds. So that is this button, what I have shown you here. So that actually breaks it up and it makes an orthogonal corner over there and here, and therefore it adds these 3 edges, and this particular, it is not exactly stretching. Now using these 6 commands, you can actually lovingly reshape TAD shapes to whatever shape you want, consisting of straight lines. As you can see, I never had to delete a particular edge and remake that. That is something which is rigorously not allowed here, and there's a very good reason for it that I will explain to you shortly. But let me finish this third button also. The third button is actually to change the edge into various types of curves. Like for example, if I want to have a semicircle over there, I can just say I want a semicircle, but that by itself will not change it, and I will now press that button. It will become a semicircle over there. Now if I press F3 and F4, I can actually get the helpers around that whole shape and do whatever I were doing with the helpers and the architect in the earlier first 2 videos were explaining all that quite well. So there you have it. I've actually changed the shape of a particular TAD object. Initially maybe you thought they were only rectangles, but no, you can do all kinds of shapes with it. Okay. I personally do not use much of curves as such. I have, it's not that I have not, but it's up to you what you want to use and not use. TAD does not really dictate. Now TAD today does have a limitation in geometrical modeling. It doesn't do a full dome. Neither it does a one of those wavy shapes which is known as a NURBS patch, like okay, non-uniform rational B-splines, if you want to get technical about it. So these kind of Zahadi type of curves and all is currently not possible. It's not that I don't want to give it. I thought that 95% of our projects don't really use those kind of curves, but I may be wrong. There will be architects who predominantly use those, and I am talking from a developing countries perspective where the construction details have not really gone beyond the plumb and the water level. So we are literally in Egyptian technology even now in many developing countries. Anyway, so that's what actually editing is all about. You can just go around placing the architect, placing the helpers, and once you get it right, sometimes you may end up, I'll show you one common mistake which people do when they start off with TAD, is that they are looking here and they take the architect here, and then they probably want a corner between these edge. Now they have placed the architect here, but the helpers are still here, and then they will add a corner, and suddenly some very odd shape has come. Obviously, it is very rigorous about its grammar. So if it says that it can only add a corner between the first helper and the second helper, the way it was, as you can see, it was earlier here, okay, and the first helper was here and the second helper was here, and it will only add there and nowhere else. So it is going to be pretty rigorous about that. Now you get over this in about 10 minutes or so of using TAD. You will know that, okay, I have to place the helper in the right location, place the architect in the right location, and go about editing it. You won't believe it. People initially, when they see this, then they say, you have only 6 buttons to edit. Can you really edit a project with this? Yes, you can. I have done thousands of projects, and from simple projects to complex projects, and they're all done with this. That's it. Actually, it's very easy to use this. Now comes the question, conceptual question, that why did I just give this way of editing? Why am I not allowing? Why am I so serious about not allowing the deletion of one of the edges and then reconstructing it with some other shape which you want? We have done that in AutoCAD all the time. It happens. Like if I were to use NanoCAD, let me start a new file in NanoCAD, and I will say that let me first make a rectangle here. So I'll say draw a rectangle by 2 points. So here is a rectangle, or you can say polyline, and we'll say, no, you know what, I want to erase that line, and then probably you do something like this. Erase, I think, is a command, and then you will select that. Oh, I think it's selecting the whole thing. Okay. I'm sorry, I'm not good at AutoCAD and all. But you get what I'm saying, right? If I were to make this into, I think explode should work, and explode it into 4 lines. So let me first explode this, and okay, now it has got exploded. Now what I'll do is I will say that I want to delete that one edge. Oops, sorry. There you have it. Now I've got I started with a rectangle, but then I ended up deleting one of the edges. And I'm thinking that what should I do? Now for many, this may sound very creative, that AutoCAD or NanoCAD or whatever your favorite drafting software is allowing me to create an imperfect shape, and it allows me to think over it. Well, maybe it is, but it has got some serious logical problems here. And the problem is explained by this cover of this particular takeaway box which I got. Now think that you have modeled this particular cover, right? Now what TAD says is that we are not doing drafting, we are doing actual modeling. So when you're talking about actual model, you can never have any shape where one edge is missing, the way you can see in the in this particular NanoCAD file, that one edge is completely missing. You cannot say, take this particular cover of this takeaway box and say, let me remove just this particular edge from here. It's not possible. There is no way you can remove that. I mean, it defies logic. Now, such type of illogical structures have a technical name. They are called ill-formed entities. The entity is not fully complete. What are these ill-formed entities? These are entities which actually have got no logical definition inside the computer. Now let me show you this fish processing plant which I got from the net somewhere. I downloaded as a sample file. It was a free sample file, DWG file, and as you can see, it has got lots of lines here, and some of them are indeed shapes which you can click on and then find out and all. And there are also dimension lines and things which are not really seen in the actual actual world outside, but they are like graphics. Okay, now if I were to remove one of these lines, okay, let me do the same thing. I think this is a closed path or whatever, so I'll explode this again like I did in the earlier this thing. And now let me say that I've deleted that edge over there. As you can see, I have deleted the edge of that. I don't know, it's representing some tabletop or whatever it was representing. Now let me zoom in, and if I ask somebody and say, come over and take a look at this drawing, do you seriously think he can detect where that error is, where it is actually not lost? I myself lost that, I think. Where was it? I think it was, oh my god, in this there it is. So this is where I have made it illogical. It actually is incomplete, and it is an error over there. And if I ask anybody to go and detect that error, it's going to be a pretty thankless job if this is the amount of lines which are there. But that apart, if I were to write a program to go and search for these illogical structures inside that particular software, do you think the software will do anything better? No, it can't, because there is nothing like a set of alphabets in graphics. In English, we have 26 alphabets. So you can actually ask a computer to go inside a text file and check whether those alphabets are there or not. So either it is there or it's not there. You cannot have an alphabet halfway between B and C, for example, or half complete B. Nothing is like that is ever possible in a text file. Either that B is there or it is not there. Okay, but you will not have an intermediate situation the way I have modeled it here, where you have half a complete particular tabletop. Let's say it's a tabletop here. Now what happens is, somebody will say that, no, let me say that I can add that shape back. Okay, let's say that I added this shape back. Let me go to the simpler version of this particular example, and I will give the line command here, and I will say specify the first point, which is this, and specify the second point, which is this. Okay, and somebody will say, you know what, here it is complete again. What is the problem? No, it is still a problem, because what has happened is that you visually can see it as a rectangle there. But does the maths inside the software see it as rectangle? No, it is not seeing it as rectangle. Let's say that the initial 3 lines, let me do it again. Let me join this. There is a command in AutoCAD, I think it is there even in NanoCAD, it should be there, is to join 3 distinct lines as one. Oh, that join command doesn't seem to be there, I think. I'm not sure whether it's there. Let me see. Maybe in this version it is not there. No, it is saying it is there. So I have to select the source object. Oh, I didn't do that. And I have to select this, and then I have to press enter. Okay, so now what has happened? Oh, even then it didn't join. I'm sorry, I've got something wrong here. Okay, my bad. I'm not very good at AutoCAD or anything. But there is a command by which you can join these 3 lines into one polyline. Okay. Now when you join this in one polyline, what does AutoCAD or NanoCAD do? It says, okay, here is one polyline and it's got 3 segments in it. Continuous, right? And then you went and added one more line over there because you were in that creative state where you removed a line, then you thought about it, and then you added that line and all that. So let me grant you that freedom for now. But look at the damage which is done. The damage is very insidious. Very, very insidious. Insidious means you do not know whether the damage is there or not there, because visually it looks like a rectangle, not a problem at all. But technically, internally, it is stored the data in 2 different parts of that file. One part has got the 3 segment polyline, and the other part is that additional line which you have put over there. Now let me go back to this complex set of lines here. And if you have this complex set of lines, and if this kind of editing mistakes have happened somewhere or the other inside this, how on earth are you going to detect it? Not just you detecting it, how on earth can any software internally detect the inconsistencies? It is not possible to detect it. I mean, they have tried. They have this join command. When it came, when I started experimenting with CAD software, I realized that this is a huge mistake, logical mistake. But when the join command was invented by AutoCAD, and I was pretty impressed. I said, wow, this is pretty nice. I can, make separate line and then join the whole thing into one polyline, and, the deed is done. But the problem is that the fact that the software allows you to keep the data in a corrupt manner where one of the edges is missing or a few of the edges are missing, and there is no, and then even if you put it back, if all you have to do is to forget to do the join, and it remains in a corrupted state, because that one part of that object was a polyline, like these three segments would have been a polyline, and that is kept separately in the file separately, and this, the top line, is kept separately. What I mean by separate means it's not that there are two different files, but in the file, in the database, in the memory of this particular program, the computer has no choice but to treat these two things as two different things. That's why you can edit that, right? That's why I can go and shift that line later on if I want to, for example, right? So this leads to inserting ill-formed objects inside the computer. Now, this is not a good sign at all for doing any logical calculation. For this, let me pause a minute, and some of the architects from India, you must have experienced some of this municipality drawing, automatic drawing checking software. Some companies have gone and given their solution to various municipalities and convinced them that their software can automatically check all the FSI. They are lying through their teeth. Okay, what they are doing is they are insisting on certain conventions which you have to follow when you are making such drawings. So the problems which the software itself has because of inconsistent graphics or ill-formed objects, they are trying to tell the architect making those drawings for the municipality that please, you have to do this in this layer and that in that layer, and please, you must use polyline here and you must use polyline there, otherwise we will not be able to tell you. So it goes through unnecessary rounds where you have to submit it and they will check it and they'll return back a report, and then you have to further work on it. Somebody has to say, this is crazy. This is not the way you really have to talk about logical entities of a building. A building has got logic, very much like this cover of this takeaway box has got a logic. It's a cover. There is no way by which you can have an edge which is missing. Exactly the same way in TAD, whenever the shapes are there, these shapes are always going to be well formed. There are only a few inconsistencies, like that example which I showed you where you could make an illogical shape like this. Thankfully, these can be very easily eliminated or prevented by yourself. And other than that, you can never have an inconsistency in the shapes which are under editing in TAD. That means at every stage of editing, you will find that the logic has remained consistently correct. So if you saw when I was editing this chajja, it was actually here, right? Let me open a new model, and it was here inside this. Then I shifted it here. But did the chajja change its name? No, it is still remaining chajja. Did it say that I am confused? I don't know what you shifted here. No, it is telling you what this is the area of this. If you remember, one of the first things which I did was to give the stretch command. Did it stop being chajja? No, it is still the chajja. When I shifted the helper, did it stop being chajja? No. And each time it is giving you the correct dimensions and the correct areas. And this saves a ton of time, huge amount of time. See, here I got it inconsistent again. So I didn't take the caution to make the helper at the right location. So now I change this here. Again, the shape has changed. But does it think that it is not chajja? No, it is still chajja only. You are editing it. And as it went through the edits, it is still giving you the logic of that. And this is one major reason that I was not able to work on some other software. Like I could not use AutoCAD and then extend that and then add some Autoless routine and do all these things. It is impossible. It is thankless. It will do some silly things, and I'll have to force you to say that you have to use layers and you have to use this convention and you cannot use non-poly lines and you have to close the poly lines. All kinds of things you have to throw at it. And if your draftsman accidentally leaves behind, like I did in this particular case, I actually deleted one of the edges. Now to go around searching for that, where that hell that inconsistent ill-formed shape is absolutely impossible. It is not possible to detect where you may have done some mistake. So this needs to be fully appreciated and understood. This saves you a huge amount of time, because there is no way as you edit the shapes that TAD is going to get confused and say, I don't know what, till now you are doing this, calling that the living room. Now you're calling something else the living room because the shape has changed. No, it is never going to happen in that. That's the reason. Let me show you one very dramatic display of how TAD does the municipality calculation. Now I have loaded a file which is prepared for that, and I can just load this extension called BMC, Bombay Municipality FSI calculation, floor area ratio calculation, that is, and I click on that and immediately it has given me all the logical listing, and it's absolutely correct, and you're getting it in a second. Right? And you can also extend it for various calculations. Now if I say let me edit one of these shapes, I will just do a shortcut by pressing the shift key as I drag this. Now I have changed the shape of this. Does it get confused? No, it will not. It will now tell you the new values of this particular if you were paying attention to the FSI values here, which it was showing that this is what the area is, like now it is 1396, okay, FSI area as per BMC is 1396 area. And if I were to say undo it, and if I click on that, it will say that the FSI area would be lesser. It is 1387, which is there. So it is doing the exact accurate value. So you are continuously changing the design. Remember I told you about abductive logic and why we need to work through various different alternatives, then cherry pick the one which we really want to take it ahead based on some criteria. This is what happens actually, that when you edit in TAD, let me close this, you edit in TAD, TAD is always kept the logic always consistent. This is also one reason why you should not delegate this software to somebody else who's a junior, because juniors may not be so experienced in figuring out, is the FSI important, the quantity calculations important. They are not in that frame of mind. So they may not even understand why you need this. They'll wonder, why can't I just erase that line and change the shape, what I do in AutoCAD? Like, this problem is always seen in drafting software. It is seen in SketchUp, it is seen in AutoCAD, of course, it is seen in all the non-BIM based software. In BIM software also, surprisingly, some of these things are still there. And that's why the current approach for BIM is also, according to me, pretty wrong. Not just for this reason, for many other reasons. Let me not get there right now. But this is the basic essence of editing. All you have to do is to just learn these 6 commands and you are sorted. There is nothing which you have to get worried about in editing any shape. You can get into any kind of shape. Let me load some other designs of mine here. Let's see what this Geonics office building is. So if you see this, I had done this never get built. This is one of my unbuilt projects, and this is a 3D of it. It doesn't have curves. I have very few buildings with curves. There are some buildings which does have curves, but this is what it is. You can do all kinds of elaborate things in TAD, all kinds of complex things. Now, if you thought that I'm showing very few lines, let me load that hospital once again. Last time I think I showed you in one of my demos. It's got lots of lines here, but none of them are illogical shapes. Everything are continuous and it can't be broken, and I'm making Donald Trump kind of gestures. You cannot break any edge and then change the shape and things like that. This is not a drafting software. So I hope you understood how editing happens in TAD and why that is the only way by which you can really be very consistent about it. There are a few other software which does have some pretty logical relationships, like I think Vectorworks has a few for spaces and all that, but none of them are consistently accurate and logically correct all the time. If you see, it never really stressed you. Once you start using it and once you get adopted it, I bet you are not going to go back into any other form of editing. In your mind's eye, you are actually fiddling around with these rubber bands to create the shapes. That's how it works. Okay, I hope you enjoyed this. If you have any comments, please join the community and then quiz me there, and there are others there, and we can sort out whatever doubts you have. Thank you very much for paying attention.